Hi, so we are going to cover a few more things about functions in this video. So the first thing is what I show here, the code that I define a function for, and all that it does is the first for, and then I call it, right? The interesting thing I do here is I redefine for and print that in the second incarnation of for, I said this is the second one, and then I run it again. Okay, so Python allows us to redefine a function with the same name. Okay, well, so let me just run just the first one. There shouldn't be any surprise here. It will just say the first one. Now, if I redefine it and run it again, well, guess what happens? When I run the for the second time, which for do I run? Well, I can only run the second definition. So if a function is redefined with the same name, only or redefine multiple times, right? You can redefine it 10, 20, 100 times, whatever. Only the last definition remains. All the previous definition, they are all overwritten. They're gone. Okay? So that's one interesting thing about function definition or redefinition. It gets maybe slightly even more interesting. So what if I redefine a function but with a different parameter list? Right? I add an a here. Can I do that? Well, when I try to run it, no, I cannot, because the latest definition of foo, the definition that survives, requires a parameter a, and when I call it here, it does not. I'm not passing it a parameter, so that's why it's not happy. So I want to point this out because, especially because in the language C++, C++, and Java, you can have multiple functions with the same name but different parameters. Okay, so for those of you who know C++ and Java, Python is different in this regard. That when you redefine a function with the same name, it's just that last definition is the one that's valid from that point on. Okay, now one more crazy thing that you can do is that we can even redefine, quote unquote, some of the built-in functions, such as range. Okay, and I can say this is a bat range, and then I can call range here, as you would expect. This is a bat range. Then you know how we usually use range, right? We say for range, for I in range 20, blah, we print out I, for example, right? Now, this will no longer work because the range that we defined really kind of shadows the built-in range. So in order for this to work, we have to get rid of our own range, and then the original, the built-in range would once again be accessible by our code. So usually, I think most of the time, you probably don't want to redefine any of the built-in functions. There are times that you might want to, but very rarely, and certainly not in this class. Okay, let's see what else I want to say. Yes, one more thing. So not only you can, let's say I'm going to bring back my for, and I say whatever for, okay. not only you can redefine a function with the same name, you can create a variable with the same name. And if you do that and you try to call the function, so here I create a variable called full, and where I already have a function named full, and then I try to call the function full again, well, guess what? It's not going to work because now the name full is no longer a function. The name full is an int, and it says it's not callable. Well, because it's not a function, we cannot do that. Okay, so just be very, very careful when you name your functions and name your variables. And actually, the reverse is also true. You can have a variable, and then you can have a function with the same name, and that function would then hide the variable. Okay, so it happens both ways. So, kind of the summary is that within all the accessible scopes. So what that means is for the code in the global scope, the global that's the global scope, right? That's the accessible scope. But for a function, the accessible scope is its local scope, things you define inside a function, and also the global scope. So within these scopes, a name can only be associated with a single value or a single function. Okay, so be very careful when you name things. Be associated. Excuse me. All right. So next thing I want to talk about is just a little more a little more about the return statement. So we know we use return to return values, things from within a function. Okay, so what do you think happens in this particular function? That when I come into full, I print something, and then I return here, and I do something after the return statement. Is this code going to get executed? Well, no, it doesn't appear to, right? That's because return immediately exits the function, okay? And if you actually heed the warning of PyCharm, it says this code is unreachable. Like, you already returned. Why are you trying to do things after return? That code is never going to be executed. Okay? So that's one thing about return. And here's another very interesting thing. What if I have, let me comment this out. What if I have an empty function? Right? Remember, we actually can make an empty function. And what does it's a function without any return statement, right? What does function like that return? Does it return anything? So we call it here, and let's print out what it returns. It returns none. Okay, so none is actually a thing. It's just a thing that means nothing. Okay, and believe it or not, we're going to be using none a whole lot later in the course. But for now, that's all you need to know, that none represents nothing. Okay, so for a function without a return statement, it still returns a thing that is none. Okay, what about if we just say return here, and we're not returning anything like a number or whatever? Well, let's run it again. Okay, so here we go. When there is just a return all by itself, it also returns none. Okay, it's like, I'm done. I don't know what to return, so I'm not returning anything. And what the caller would see is that it returns none. And finally, we've been using none so much, you can explicitly say to return none. Okay, and in that case, well, you'll see none. So there are multiple ways for a function to return none. You probably should pick a way that is good for the readability of your code. Okay, so that's what the slide is trying to say here. And finally, I hope it's kind of obvious. I mean, a function is not limited to a single return statement, right? Especially in the case of branching code. So in this case, I define a function, what to do given the traffic light, right? So if I say light is green, well, it should return go. And then if light is yellow, return prepare to stop. Otherwise, it's red, we return it should stop. Okay, so again, it should be obvious already, but I just want to point out, yes, a function can have multiple returns in multiple branches of execution. And as a matter of fact, it would be very odd if in one of those branches that it does not have either does not have a return statement or return something that is different or a different type from the rest of the branches. So that would be odd. Typically, all these branches, when they return things, they will return things of the same type. Like in this case, it's going to be all string. There are going to be exceptions, of course, to all rules, especially when we have to handle errors. But in most cases, all branches should return values of same or similar type. Okay, so that's the end of this video.